Welcome back, everybody. We are going to start the second half of Unit 6 today. So we're going to start with Lesson 13. That's where we left off. And what we're going to talk about this second half of the unit are features of trigonometry graphs and how we find the features of those trig graphs. So let's first go through the lesson notes here. So there are three basic features that we want to talk about in this lesson: the midline, the amplitude, and a horizontal shift. You might remember from the first half of this unit, we've looked at some trig graphs, and most trig graphs have this wavy shape, with the exception of obviously the tangent. But sine and cosine graphs generally have this same wave shape. So wave shapes have high points and they have low points. So the midline is a horizontal line that runs halfway between the high point and the low point. So wherever those 2 points are, the midline is halfway between them. Okay. The amplitude is the distance between the midline and the high point, or the midline and the low point. Basically, you count the amount of space between the midline and either the high or low point, and that is what we call the amplitude. And then the horizontal shift, well, that's pretty self-explanatory. We looked at horizontal shifts in Unit 5, okay, and a horizontal shift is the amount by which the graph is shifted left or right. So remember from the first half of this unit, the cosine graph tends to start at 1, goes down to -1, and comes back up to 1, okay? And then the sine graph starts at 0, goes up to 1, down to -1, and back up to 0, okay? If that's shifted at all left or right, then we have a horizontal shift. So for today, we're going to talk about how to find these features from an equation. And how we find it is right in here, whether it's sine or cosine. So when I add a number outside the parentheses after the sine or the cosine, that number, and in this case, it's denoted by the variable d, that is the midline. All right, and it says here, if there is no d, then we assume the midline is at 0, okay? The number that we multiply by the sine or the cosine, in other words, the number that's directly in front of sine or cosine, that number is the amplitude. Actually, the absolute value of that number is the amplitude. So and basically what happens is if the a value is negative, the absolute value of a negative number we know is positive. So the amplitude is always going to be positive. So we find that by looking at that number a that's directly in front of sine or cosine. And then the shift, okay, that's going to be the number that we add inside the parentheses, okay? And you might remember from Unit 5, when we do horizontal shifts, it goes by the opposite. So if the C value here is positive, okay, positive would normally mean a shift to the right, but the opposite would be left. So if C is positive, the horizontal shift is that many units to the left, okay? And conversely, if C is negative, the horizontal shift is that many units right. Negative would normally mean left, but the opposite of left is right. All right, and if there is no C, then there is no horizontal shift. So that's kind of the basic premise of today's lesson. What we're going to do is we're going to look at the features of these graphs through the application of a windmill. A windmill goes around in circles, so we can apply trig graphs to that. More specifically, we can apply the sine graph to how a windmill rotates. So the amplitude of the sine graph represents the length of the windmill blade. If you think of how a windmill spins, all right, the length of the blade is the radius, all right? So the length of the blade, or the radius, is going to be your amplitude of the sine graph, okay? If the a value is negative, all right, so if the amplitude, so if this a value is negative, then that means that the windmill is spinning in the negative direction. So remember, negative direction means clockwise. Positive direction means it's spinning in the counterclockwise direction. Okay. The midline of the sine graph represents the height of the center of the windmill blade. So you have a windmill, you have different blades, whatever the height of that center is, that's going to represent the midline of the sine graph. And remember, the midline is going to be that D value right here, okay? And the angle position where the windmill starts at represents the C value and the horizontal shift. So the angle position where it starts at, okay, represents the C value. So that's this one. And then in which case that would be also the horizontal shift. So if it starts at the 0 degree or the 0 radian position, which remember is directly right of center, then the C value would be 0, so on and so forth. Okay? So with that in mind, let's go and look at our first set of examples for this lesson. So suppose a windmill has a radius of 1 meter. Okay. So it has a radius of 1 meter. Okay. And the center of the windmill, okay, that center is at 0, 0. Okay, so that tells me we have a unit circle. Okay. So the center is at 0, 0, okay, on a coordinate grid. Write a function describing the relationship between between the height h of w and the angle of rotation theta. So we know when we write our equation, we know that it has to be sine. So the question is, what numbers are we going to fill in here? So let me make this look a little nicer. And let's go back and look at our lesson notes. So first of all, our radius has a length of 1, all right, has a radius of 1 meter. So the radius, or the length of the windmill blade, tells me the amplitude. So in other words, the amplitude is 1. Okay, so that's going to be the number that goes in front of sine. So I'm going to put a 1 in front of sine because the radius is 1 and thus the amplitude is 1. Okay. The center of the windmill is at 0, 0. So in a coordinate plane, that would be the center. That would be the center point. So the height is going to be 0. So the center of the windmill in this case has a height of 0. Okay. So the height of the center represents the midline of the sine graph. Okay, so the midline is going to be at 0. So that's going to be, remember, that's going to be the D value. So after that, so I'm going to put a plus 0 over here. Okay. Then we're starting, W is starting directly right of center. So directly right of center is the 0 degree position, or the 0 radian position. So if we go back to our lesson notes, the angle position where the windmill starts at represents the C value. So the C value in this case, is going to be 0. All right. For this particular example, we don't have to worry about B. We only have to worry about A, C, and D. So C in this case is going to be 0. Okay. So if I rewrite that, okay, 1 times sine, well, 1 times anything is 1, so I really don't need to write that. So my equation is going to be sine of theta plus 0. Again, I don't really need to write plus 0 because adding 0 doesn't change the value. And I also don't need to write the plus 0 outside the parentheses because, again, adding 0 doesn't change the value. So the function describing the relationship between the height h of w and the angle of rotation is going to be sine of theta. So that's number 1. This is the answer to number 1. Okay. Number 2, describe how your function would change if the windmill blade has a length of 3 meters. So describe how your function and its graph would change if the windmill blade has a length of 3 meters. So if it had a length of 3 meters, okay, that would mean that the radius would be 3, which means the amplitude would be 3, which means the A value would be 3. So this number directly in front of sine would change from a 1 to a 3. So it would essentially change to h equals 3 times sine of theta. And if it had a length of 0.5 meters, it would be h equals 0.5 times the sine of theta. Okay, so test your predictions using graphing technology. So we're going to graph these on Desmos. Okay, so we're just going to do our graph between 0 and 2 pi, since that would be 1 full revolution. Okay, so we're going to graph sine of theta, or sine of x in this case, and then 3 times the sine of x and 0.5 times the sine of x. Okay. So if I zoom out just a little bit, you can see if my radius was 1, then my graph would be sine, and that means I would never be more than 1 meter away from the center, which remember was at 0. Okay? If my radius or length of the windmill blade was 3, then I would go 3 meters away from the center. Okay? And if my radius was 0.5, let me zoom in a little more. Okay, notice I wouldn't go more than a half a meter away from the center or the midline. Okay, so our predictions are correct. Okay, so that's the first set of examples for this lesson. Let's go to the second set of examples. So number one, a windmill has a radius of 1 meter and its center is 8 meters off the ground. Okay. The point W starts at the tip of a blade in the position farthest to the right and rotates counterclockwise. Okay. So now we're going to write a function again. So we know it's going to be sine of theta. The question is going to be, what numbers do we have to fill in? So let's start with our radius of 1 meter. So our radius of 1 meter tells me that the amplitude is 1. Okay. So the radius is 1 meter, so the amplitude is 1, which means the A value in front of sine is 1. The only question is it going to be a positive 1 or is it going to be a negative 1? So the radius being 1 meter, all right, and the fact that it rotates counterclockwise. So rotating counterclockwise means it's rotating in a positive direction. So that tells me the A value is going to be a positive 1. So I've used the fact that the radius is 1 meter, and I've used the fact that it rotates counterclockwise to determine that this number here is 1. Okay? The point W starts at the tip of a blade in the position farthest to the right. So farthest to the right would mean directly right of center, which means it's starting at the 0 degree or the 0 radian position. Okay, so the angle position where the windmill starts at, in this case, it's starting at 0, represents the C value. So the C value is going to be the plus value after theta. In this case, I wrote X inside the parentheses. So I'm going to put a plus 0 inside the parentheses because it's starting at the 0 radian position. So we've used that fact. Okay. And then the only other thing we haven't accounted for is that the center is 8 meters off the ground. So the height of the center is 8 meters. Okay. So the midline of the sine graph represents the height of the center of the windmill. So the height of the center is 8. So that means the midline is 8. If the midline is 8, then that means this D value is going to be plus 8. So after the parentheses, I have to write a plus 8. So if I rewrite that, just like before, I don't need to write the 1 times because 1 times anything is itself. So it's going to be sine of theta, and I don't have to write the plus 0 because adding 0 doesn't change anything. So it's going to be sine of theta plus 8. Okay? That's going to be the function for number 1. Okay? Number 2, graph your function using technology. How does it compare to the graph where the center of the windmill is at 0, 0? So remember, when the center of the windmill is at 0, 0, it's just going to be, and we saw this before, is sine theta. Okay? So if I compare sine of theta, so if I take my sine graph and I compare it to sine of theta or sine of x, plus 8. I'm going to have to zoom out a little bit. Okay. Notice it's literally the same shape. It's just the one where the height is 8 is shifted up 8 units. Okay. Other than that, it's the same exact graph. So for number 2, okay, the graph of the function where the center has a height of 8, okay, is the same as the graph of the function where the center is at 0, 0, except it is shifted up 8 units. Okay. What would the graph look like if the center were 11 meters off the ground? Well, instead of being shifted up 8 units, it would be shifted up 11 units. In other words, the equation would be sine of theta plus 11 instead of plus 8. That would be the only thing that would change. Okay? So again, the purpose of this lesson was to practice writing equations, all right, where we have a windmill using the amplitude, using the midline, and using the horizontal shift and applying that to a windmill situation. Okay, that is it for lesson 13.